Hello, and welcome to my first video. First in a series, I hope, a short series that will compare the speed of the basic built-in interpreted basics in the various ROMs of vintage computers from the late 1970s to the mid-ish 1980s. Why am I doing this? Just for grins, just because it's fun. It's a kind of an apples to oranges comparison, I understand, but I think it'll be just fun to see how these computers fared against one another for some very common programming problems that might need to have been done back in the day. So today we're going to be calculating prime numbers, and we're going to be calculating prime numbers on 3 different computer models from the early to mid 1980s. And our first model here is a Commodore 64. This is a 1 megahertz machine. So if you can compare that to today's multi-gigahertz monster machines, this would be, by today's standards, incredibly slow. It has a MOS 6510 processor in it, which was a processor development company owned by Commodore at the time. Has an 8K Microsoft BASIC in it. And that's about it. And let's move on to our next competitor. This is a Tandy 102. It has an Intel 8085 in it, running at about 2.4 megahertz, so a little over 2 times as fast megahertz-wise than the Commodore 64. Came out in 1983. The 64, if I haven't already mentioned it, came out in about 82. Finally, our third candidate. An MSX machine. Now these machines are a little bit later than the Commodore or the Tandy. These came out 84-85 time frame, I believe. There's a North American NTSC model, which is somewhat rare. It's a Yamaha CX5M. It's a MSX1. This has a Zilog Z80 processor running it at 3.58 megahertz. So seems pretty speedy, right? Almost 3.5 times as fast as the Commodore's processor in terms of megahertz rating, but we shall see. Who will come out ahead, the MSX, the Tandy, or the Commodore 64? Let's find out. So just to talk about the program that we're going to be doing the speed comparison with these 3 machines. This is a prime number generator. What you do is you type in the number, the upper limit, meaning find the primes up to this number. So if we, on the Commodore 64 here, find the primes up to 25, you'll notice it printing out the numbers that are primes. It'll put in a dot for numbers that aren't primes. And it works the same way in all 3 machines. All 3 machines have very similar basics. They're all based on a Microsoft Core BASIC. The Commodore has a 8K BASIC, very tiny. The Tandy and the MSX have I believe they have at least 16, maybe 24K basics, so a lot more commands, a lot more fancy basics in them. So let's get the Commodore running here again. And what we will do is we're going to calculate primes up to the number 250. They all, again, have the same exact basic program in them, almost virtually identical code in each of these machines. And let's see who comes out on top. So Josh, on the count of 3, if you'll hit return on the MSX machine, please. And I'll hit return on the Tandy and the Commodore. 1, 2, 3. Okay. So, Commodore's at over 50. The Tandy is just reaching the lower 40s. And the MSX is also in the 50s, 60s. So far the Commodore and MSX are both kind of on par and in the lead. Let's see what happens here. This 1 megahertz Commodore is in the early 100s. The MSX has slowed down a bit. It's just now reaching 100s. The Tandy still hasn't broken 100. So the thing I want to point out with this prime number generation program, it's basically testing these early interpreted basics. The smaller the basic, like in the Commodore, an 8K basic, it had less parsing work to do. So it had a smaller number of tokens to figure out. So it may be what we're looking at here, if the Commodore is in the lead, is the fact that the smaller, tighter basic has less work to do, and just in terms of its parsing. The Commodore is ahead in the lower 200s, almost reaching 250. MSX is second at about 167, and the Tandy is about 131. So it is third. The Commodore just finished. 79.32 seconds. So a minute. We're looking at, what is that? A minute and 20 seconds. So to generate primes up to the number 250. The final prime is 241. The MSX is still cranking along there. Again, the MSX has a fancier BASIC. Even though the megahertz rating on the machine is faster at 3.58 versus 1, it has a lot more token parsing to do. So I think... Now, the other thing that this thing's stressing on each of these BASICs in terms of workload is the display. The character display for each of these machines operates very differently. They all have different chipsets and different ways of interacting with that chipset from the BASIC interpreter. And the Tandy here, the 102, is probably the weakest in terms of its display. It's got this old LCD display from the early 1980s, so I'm sure this is affecting its performance quite a bit. At some point in the future here, I might post some timings on this Tandy that doesn't include the display time. We'll see if that makes a difference. So, the MSX is finished. 148 seconds, basically. So, we're looking at well over 2 minutes. So, roughly half as fast as the Commodore 64. So, we have a 3.58 megahertz machine and a 1 megahertz machine. The 1 megahertz machine has beaten is roughly twice as fast as the faster machine there. Again, we're talking different, even though they have Microsoft BASIC cores in the ROMs, each manufacturer has implemented their own add-ons and features to the BASIC and manipulated the BASIC code. But nonetheless, the Commodore is twice as fast as the MSX, and the Tandy is still struggling along here. It's up in the lower 200s, so hopefully it will finish up here soon and we'll get a final tally. 227. And looks like it's gonna get there. It's poor thing. And the Tandy, the 8085 in it, it's a CMOS processor, so it's meant for low power. It's meant to run on batteries, unlike the processor inside the C64 here or the MSX machine, the Yamaha. It will get there. It's awfully close. I think it's got one more prime to calculate. There it goes. So we are looking at, from what I can tell, 4 minutes, just over 4 minutes, so roughly 4 times as slow as the Commodore 64. Is that due to the particular BASIC implementation on it? Is it due to the fact that it's a CMOS processor, even though it's running at 2.4 megahertz, more than twice as fast as the Commodore in terms of sheer megahertz rating? Is it, is it due to the display processor? It'll be interesting to see. I'll try a different BASIC or a different variation of this program on there, generating primes that doesn't spit out the numbers as they're being calculated. So, as a summary, Commodore 64 in the lead, just over a minute. The MSX second place. Commodore beat it. Commodore was twice as fast as the MSX. The MSX had the 3.58 megahertz Z80 processor in it, and finally, the 2.4 megahertz 8085 CMOS and the Tandy 102 portable, 4 minutes, 4 times as slow as the Commodore. So for right now, until our next video, the Commodore 64 is in the lead. Thanks for watching.